So we move to our next item, and I'm sure this will be of much interest also to various students who are here. Several alumni now of our various educational programs will now tell you about their life after their fusion studies, what is happening. First is Mr. Daniel López. He is a PhD researcher at the same laboratory of plasma physics at Royal Military Academy in Brussels. Please.
Yes, hello, can you hear me? Okay. So thank you for the introduction. So my idea for this presentation was to do like a summary of my academic work in fusion and how I decided to study fusion in Belgium specifically. So this presentation will be quite short, but it's like quite almost like a promotion of our European masters and the possibilities that we have to study fusion in Europe. So first, my motivation. So why did I want to study fusion in Europe? As you can see in this map, this is a map from the International Atomic Energy Agency. In yellow, you can see all the tokamaks, and in red, you can see all the stellarators. And here, it is very visible that they are mostly located in Europe and in the North America and in East Asia. So not many points in Africa or Latin America. But if you zoom in this specific part, this is Costa Rica, and I am from Costa Rica, so we have 2 points here, a small tokamak and a small stellarator. So for me, studying physics, that was quite something, because it was a very good possibility to do something related to fusion. So I was interested in this, and during my bachelor, then I applied to work at this plasma laboratory in Costa Rica. You can see here a picture, a very old picture of one of the first prototypes where they were testing the construction for the first stellarator. And here is a picture of the stellarator s.r.o, which is the one that we have in Costa Rica. So I was working there doing some, you can see this is a tabletop machine. It's very small, but we could do some interesting physics. And when I finished my degree, so I wanted to, well, when I was doing in my bachelor, I wanted to help more to the lab and to work on the projects. So I wanted to learn more about fusion, and they organized a summer school in Costa Rica, and this was in 2014, so 8 years ago. And you can see a picture here with many familiar faces from the Belgian fusion community. So here is Jeff, and you can also see Professor Van Oost and Notre Dame and Koch. And during this summer school, so that was my first introduction to what has been done in Belgium in general. And also, I learned about this program, which is called European Masters of Science in Nuclear Fusion and Engineering Physics. So this is a master program about fusion specifically that has a collaboration of many universities in Europe. So you have Ghent University in Belgium, and also universities in Germany and France and Spain. So the idea of this masters is that you can choose 2 different countries. So you go 1 year to the first country and second year to the second, and you do your thesis there. So I will show in this presentation the work that I did during my master's and all the different contributions and the different experimental opportunities to contribute in projects that I have during these 2 years. So I decided to go to Spain for my first year because I was from Costa Rica, so I was already speaking Spanish, and it was easier for me. And in Spain, they have the stellarator TJ2, so you can see there is a big difference if you compare it to the one from Costa Rica. This is much bigger, so it was great to have classes there and to be able to see the real experiments and to be in the control room and see the real results of this accelerator. And then during the masters, you have also the opportunity to work on several like sort of internships where you go to different countries. So this is what I did in Spain. And then we also, okay, so here's a picture of the coil. So you can see that this is a accelerator because it has like this very complicated set of coils. Then I also worked on Czech Republic. We had some work on compass tokamak. So this is the tokamak. You can see that it's also, well, relatively small size. And we had this very interesting work in Czech Republic in which we were able to work with real data and to generate something interesting in just a few weeks. One of the interesting factors of compass, this is a relatively small machine, but it has the same geometry as Aztecs and JET and that ITER will have. So the results that they can obtain are very easily extrapolated to ITER. So what we did in compass was to, here you can see a picture of compass and the plasma. And they have the divertor configuration. And in the divertor, they have a set of Langmuir probes called ballpen probes that we were using to measure the heat fluxes that were going to the divertor during ELMs, which are some events that happen during, at high confinement in which a lot of energy and particles go to the divertor and they interact with the material. So we managed to use the data from these probes to find what was the energy fluence going to the diverter. And as you can see, well, here are some points in these stars and these shapes that we got in 2019 that were fitted to a model that could be extrapolated to the results from Aztecs and from JET, and then to get information about what will happen in ITER. So I wanted to show this because this was a work of just 2 weeks, and for me it was very impressive because we were getting some real information that could give some help to the broader picture of fusion in general. I did this work with Johannes, which will be the next speaker, so it was a very good collaboration. Here is a picture with Golem tokamak, another tokamak in Czech Republic, a smaller one. So we did this work in that country. Then we also had an internship or like a project in France in which we work at CEA on West Tokamak, another different tokamak, which is also available in Europe. And in here, well, I work with some desorption of tungsten samples, and also on this, here's a picture of all of us during this project, which we shared with the students from the European Masters and also from the French Masters in fusion from different universities in France. And in this internship, I also worked with data from Stuttgart. So in Stuttgart, they have another accelerator, TJK, and we used data from the TJK, which for me also was interesting because it's another different accelerator of a different size. And what I did was also related to probes. We were using a very interesting set of Langmuir probes that they have in Stuttgart that they put inside the accelerator, and they can measure, well, different things. Like, for example, they measure some signals, and we were able to correlate these signals to see structures that were moving inside the plasma to study turbulence on the last closed flux surface. So it was another work with probes in another different machine in Europe. And during this work, we had a visit to ITER, which was very nice. So you can see here a picture of our visit to ITER and to the site and see all the construction, which was very, very impressive. We were also also inside the pit where you can see these holes where all the different parts will be. So, well, today we will have another virtual tour of the machine. But this is like some part of the advantages of studying studying fusion in Europe in general. You have access to a lot of different machines, and you can learn a lot of very, very interesting things. Then, to do my thesis, I came to Belgium, and I wanted to do something experimental, so I worked in Germany, in Jülich Forschungszentrum, and in there, well, they had the texture machine, but it's already decommissioned, so now they have this other device called Thomas, which is smaller, but it's based on the same geometry. So I was able to work there and to do some experiments and get some data for my master thesis. So you can see here a picture of me on top of the machine. So I show this picture because it's very nice that you have access to this machine and to really work on it and do some experimental physics. What I was doing for my master thesis was also working with probes. So we have a triple Langmuir probe and a single Langmuir probe. And I was using them to characterize the plasma because the main objective of Thomas is to study the wall conditioning, which is a necessary technique on any machine to treat the walls of the device. So one of the advantages of Thomas is that it has 3 different ways of generating plasma. We can generate glow discharges or ion cyclotron discharges or electron cyclotron discharges. So I was using the probes to characterize the plasma in these different situations and then to understand in which one of them the wall conditioning was better. Here is a sample of one of the results for my thesis. So I was measuring, for example, the density and different radial positions. So we were able to tell exactly where the density, the peak was, and try to understand where the waves were being absorbed. So here is a video of one of the discharges, and you can see that the plasma is located mostly on the low field side, and this is what I was getting from the probes, like a lot of density on the low field side. So the idea of this study is to experimentally measure the profiles and then try to understand them. For example, now I'm trying to do this characterization of the plasma. So on Thomas, we have an ion cyclotron resonance heating antenna, also developed by the lab at the Royal Military Academy. So I am currently working using the antenna to generate plasma and then using the triple probes to try to characterize everything and using simulations to try to understand how the waves are being absorbed and why we have peaks in these positions and how we can improve them in order to treat the samples better for wall conditioning. And now, so part of my So I did my thesis in Jülich, and I graduated, and then I applied for a PhD position at the Royal Military Academy because I already, I knew the system, and I wanted to continue this collaboration and these studies on Thomas. So as Jeff mentioned, this is a very important lab, and they have collaborations with many of the top research projects in fusion, like ITER and JET, and you can see like almost all the biggest experiments, and they have a lot of brilliant people that have been very, very helpful for my studies. So I started doing a PhD in the academy, also continuing my work on Thomas, and ideally helping a bit in the development of the antenna and the characterization of the plasma that will be generated by the antenna at W7X. So here's a picture of the stellarator again. So you can see that there is a big difference between the SCR1, the stellarator in Costa Rica, going up to the one in Spain, and then going to the one in Stuttgart, and now this one in Germany, which is the biggest one in the world. And so my goal is to try to help a bit on this project. of the ion cyclotron antenna on W7X. So here are some pictures. So you can see that it has like many, many different parts. So the design was, I imagine, very complicated. And there are a lot of people from our lab working very hard on this project. And the idea is to use it at different frequencies to be able to generate plasma at different magnetic fields. So you can see here on this picture where the resonance will be for different scenarios that will be tested in W7X. Now, here is a picture of some of our colleagues. So there are a lot of people from the Royal Military Academy, a lot of people from ULISH working, installing the antenna here on site at the device. And we had some visits. So this is a picture of our experimental group led by Jeff and Yevgen Kazakov and Christel Trombe, which is my supervisor for the thesis. And we have help from Maya Verstraeten. And we will work on the commissioning of the antenna, so ideally see how the plasma will be generated and try to also characterize the plasma generated by the ion cyclotron antenna and see that everything is worked well and hopefully participate in the campaign very successfully next year. So, in conclusion, I wanted to show all this so the students will know that there are like many opportunities to study fusion in Belgium. So regardless the university that you belong to, there are a lot of collaborations and a lot of possibilities to help and collaborate with different experiments. So if you like fusion and if you like experimental physics, being in Belgium and studying fusion in Belgium is a very privileged position, and you have access to, for example, all of these different experiments around Europe, and you can do a lot of things to contribute to the goal of fusion. So that was my talk. Thank you very much for the attention.
Yes. Thank you very much, Daniel. So you see how enthusiastic, even after a year and a half.
Well,
so enthusiastic that unfortunately you've eaten up all your time for questions.
Okay, yes.
So if you don't mind,
I don't mind.
You will have plenty of opportunity to discuss later.
Okay.
Thank you very much, Daniel.
Thank you.
And so next is Mr. Johannes Lips. He's, of course, also an alumnus of our educational programs, and he's a PhD researcher presently at Stuttgart University. And if all goes well, we should hear him and see him now. We see your slides, but they're in presenter mode.
And no, they're not anymore.
Yeah. Yes, thank you. Please go ahead.
All right. Thank you, Geert, for the introduction and also for the invitation to speak on this event. I was very happy to hear about it. Yeah, so I will also give you a talk about my fusion story. First, a short introduction. So I studied a bachelor in electromechanical engineering at the University of Ghent. I am originally born and raised in Ghent, so I did a bit the opposite trajectory of Daniel, starting from Belgium and then moving abroad. Then I did the master in nuclear fusion and engineering physics in the same year as Daniel was studying, 1 year at the University of Stuttgart, 1 year at the University of Lorraine in France. And since then, I'm a research assistant PhD candidate at the Institute for Combustion and Power Plant Technology in Stuttgart. And I want to talk to you, of course, mostly about my experience during my master program, but I've also included a bit of information about this choice of master program, and then also the trajectory from the masters to the job search or the job opportunities also with the master in nuclear fusion and engineering physics. So after my bachelor in 2018, I was asking the question, of course, what masters should I choose? And I was torn a bit apart between my physics interest and my engineering interest, and also, of course, my bachelor in electromechanical engineering. And both were equally interesting to me, and I found a great compromise in fusion engineering, where you need a strong physics background to tackle challenging engineering tasks. And apart from that, the Fusion EP master program was offering the possibility to study abroad, to travel a lot, and that made it the ideal program for me, offered by the University of Ghent. And there, for the students who are present, Geert told me that there are some students present there as well. I also want to give you maybe some hints there in this point already. What masters should I choose? You should look, I think, beyond programs offered by your home university. Now, that's especially true for students studying at the University of Leuven, to also consider programs offered by the University of Ghent, but also, of course, the other way around, and also look beyond Belgium, I would say. There are a lot of interesting programs, not only on fusion, obviously, and I think it makes sense to really spend some time on this and figure out what you want to do in your master's instead of just continuing what you're doing. You won't regret it if you skip some classes to figure out what you actually want to do in your master's and then afterwards with your job. Apart from that, start thinking about your master's program as early as possible. I would say end of the second bachelor maybe is a good time. For some of these programs, you really need to apply quite early. So that means, in my case, I didn't start in 2018. I was starting already in 2016 to figure out what program I want to study. Just as a tip, maybe as a hint for the students among you. And then, of course, the fusion story begins in Stuttgart for me. Here there are some pictures. So Daniel already mentioned that there is a small stellarator in Stuttgart, TJK. And I was, apart from studying German and studying my physics and engineering classes, also working as a student researcher on TJK. So here there is a plasma which was made to test some equipment actually that I built, and I was working on this probe over here, which is also a Langmuir probe that can move in 2 dimensions then inside the plasma. And I was responsible for the software upgrade of the system. Then also there were a lot of events where you would meet the other students who are studying, of course, all over Europe, as Daniel also mentioned and showed. We had a winter event in Marseille, in Cadarache, where the ITER site is, where also West Tokamak is, and where this picture was taken. And then we also had the summer event in Prague. And then the year after that, we would return there to also do more experimental work ourselves. And for me, the second year was in Nancy, where they have some great... I, of course, had courses. It's also a nice part, I think, program that you also really learn about the culture of the places where you're going. It's definitely not limited to the physics and the fusion side of things. Then, of course, my courses, and as I mentioned, and Daniel also mentioned, some practical internships at different locations where they have interesting fusion devices. And my master thesis was then a collaboration between Nancy and Stuttgart. Unfortunately, because of Corona, I wasn't able to travel as much as I wanted to, but still it was a nice experience also to then collaborate with different people from different institutes with different expertise. Here's some pictures from me in Nancy. And then this is the practical course then in Prague. Daniel already discussed it. Here you also have a picture with Daniel. Also is here the coffee machine if you make a course of 2 weeks where you want to get some results out of it, you need quite a bit of coffee, which you can also maybe see a bit in Daniel's face here. And yeah, this figure you also already saw. So we did data processing of the compass tokamak Baupen probe measurements to determine the energy flux of ELM, so edge localized modes. And then the idea is that this can be extrapolated to ITER to predict the ITER ELMs. And this was actually presented during the ITER board meeting by our supervisor, Jiri Adamek. So it's really nice also to see that things that you do during your masters have really impact and go some places. Also, the practical course in Cadarache that we did at the West Tokamak, there I was working on was a microwave mode converter prototype evaluation. So here there was a microwave mode converter, and we in the laboratory environment it was actually doing what it's supposed to be doing, namely nicely converting this mode so that it can be used in the West to going, which is then used to get long discharges in West. And I also worked on controller design for this mechanical part, while control theory, electromechanics, and that goal was to stabilize very elongated plasmas in West using changes in the colloidal coils. So here marked in yellow, by changing their current, magnetic field changes, and this can be used to stabilize the plasma. And these elongated plasmas, as well as these long discharges, are tests that they are currently doing in West, really to already test things for ITER. So that's also nice then again that you see that these things that you are working on really do have impact. I thought that was really a very nice aspect of this program as well. Then there is the ITER visit. So we were really at ITER headquarters, as is shown here in the pit where the actual ITER tokamak will be built, or is currently being built and assembled. And here there's the hall where they are assembling the colloidal coils. Great place to visit. Also, I guess that the virtual visit that you will do will be also very nice and interesting. There you don't have the limitations of access, which you do have when you're actually on site. And then I had my master thesis, which was on antenna optimization for ITER. So for a measurement, plasma positioning reflectometry antenna. And here there is ITER, and then you keep zooming in to see the component I was working on, which is really, really small, which is positioned between two blankets. And there's not a place foreseen, like there's here foreseen for big equipment. It's really small equipment, which must be happy with the small gap that it gets. And the problem is there that these blankets which surround the antenna have big influence on its performance. And we were looking in how to get an optimal work in this environment. And for this, I created a simulation code, R2P2, to simulate the ITER environment and get some design criteria for a good antenna. Then I created the antenna in the computer, which would correspond to this criteria, and then we validated the design by prototype development and testing in a laboratory environment. And that's also very typical in fusion, that you see this strong interaction between the simulations and then also really this practical aspects where there is a lot to validate the simulations, which is of course necessary because the field is not finished. It's really very active research, and it's very nice to have this interaction, I think, between both simulations and also practical hands-on things. I have couple of things what you can do with a thesis, because that's also a question that maybe some of you who have maybe written a bachelor thesis or are writing a bachelor thesis are asking themselves. You can publish your thesis. Also, if it's a bachelor thesis, you can maybe work further on this to get a publication. You can take part in competitions. I managed to get on the short list of two sub-contests of the Vlaamse Scriptieprij. I won the Niras Ondraf Award for Best Master Thesis of the Belgian Nuclear Society. Again, a hint, there's always competitions. Just need to find them on the internet. It takes some time, but it's always worth a shot, I think. And then there's the question what you can do with a fusion degree. You can work in fusion, of course. You can also work with fusion, for example, in the field of superconductivity. I know some alumni who have gone there. Anything else, basically. You know that you're not limited to fusion after studying this master program. There are some graphs from publication by Guido van Oost and a team also who is in the organization of the Fusion EP. And you can see that most people after this master do get a PhD here. And there's like a fourth maybe going straight to work. But then if you look also at the fields where they are working in, so mostly fusion, which is of course a good thing to see that this master really delivers fusion engineers and fusion physicists. And also then in all kinds of different fields, you can also definitely find a job. I need to rush maybe a little bit. I had 2 more slides, one on looking for a job with a fusion masters. So nice thing is that you have an exotic title, which makes you stand out of your competitors when you apply for a job. There's again this tension field between physics and engineering, which might be an advantage or might be a disadvantage when people are looking for a very strong physics background. Maybe you have too much of an engineering background and the other way around. For me personally, I wanted to stay in the energy field, not necessarily fusion, but I found again a very nice compromise with physics and engineering at University of Stuttgart, where I'm doing research on steam cycle flexibility by physical modeling of power plants. So it's again this physical aspect and the engineering aspect. And I'm also doing my PhD there. There I also have some hints for people who are considering this. So there's here a nice comic from PhD Comics, and I think there are really these 4 stages in every PhD, and the trick is to try to minimize the amount of being oppressed, depressed, and pressed, and try to stay impressed. For that, I would advise to look for a good supervisor, and that doesn't necessarily mean a great name from university, but really look for the person who is an expert in the field and has or makes time for PhD students, gives both enough freedom and enough support, because if you have a bad supervisor, you will feel oppressed or left alone, which is obviously also not ideal. And then you need to look for a good balance between research and other things that you do. If you do too much teaching or industry projects, you won't have enough time for your research and you will be very pressed. And if you have not enough activities, you might end up being depressed. And then finally, don't do just a PhD, do the PhD you want to do, because you really will need sufficient motivation and interest to stay impressed the whole time. And that's then the end from my presentation. I thank you for your attention.
Thank you very much, Johannes, for giving a very interesting talk, very relevant for our students here. In fact, you made it look so attractive to study abroad that I hope next year we will have any students left in Belgium. You're not present here, so I would like to take one question to Johannes. Are there any questions for Johannes? doesn't seem to be the case. Jeff?
So Johannes, in your stay in the different labs, what was for you the most valuable experience? What was the real highlight, or was everything same level, all very good? Can you give a bit more information?
So my work here in Stuttgart on TJK was really great. So I just arrived in Stuttgart, and the local coordinator here suggested that if I had time, I could work as a student job, basically, in the institute. And I really was given a task where I was working on a measurement device, and also there the freedom. Well, I crashed also some Langmuir probes in the process, and it was really a great experience to work actually directly when coming to this program, to the Fusion EP program, to be given this opportunity to get some hands-on experience. I think also the other practical courses that we did were hands-on experience, which is of course great, but they were in the second year, and then it was still great experience, but not maybe this wow feeling that you have the first time that you're allowed to actually touch something in a laboratory.
All right. Thank you, Johannes. Let's thank Johannes again. Thank you. And we move to our last alumnus. We sort of organized this according to date of graduation. We made a jump of 1 year between the previous two speakers, and now we're making, shall I say, a big leap? Or we're very happy to welcome here Mr. Michal Kazda, who especially came to us from Prague today and also visiting some companies today. He's actually the CEO of his own company, MIFRE Energy, and very happy to give you the word.
Thank you very much. I believe you can hear me well, and I will try to speak quite quickly. Only one quick notice that did you notice that after COVID, every cool event must have somebody to join remotely? So from this point of view, I think good organization today in Ghent. My name is Michal Kazda, and I come from Czech Republic. Very happy that already during all the presentations it was mentioned our country as just like Belgium, quite a significant contributor to fusion or even in our case fusion research, taking into account the size of the country. I'm also alumni of the Fusion EP program, and here in this slide I show that I was studying in 2008 in Nancy, and then in Universitas Carlos III in Madrid, and finishing my thesis in Cadarache, this time on Torre Supra. I'm honestly not sure, but this time when we were studying for European students, there was also an opportunity to spend a short time of the thesis work in associated non-European partners. So I spent some time in Hefei in China, which was very, very interesting. And I'm very thankful for this opportunity, looking backwards. And then I didn't continue in PhD study. I started to work in nuclear industry. So I think this is also the opportunity to hear for you to show that in all students in fusion, the possibilities are very broad. And this is what I would like to say is that doesn't matter. Don't to be afraid about where will be the job, how, and so on. In fusion, I like too much that it's international cooperation. There is a very open welcomed environment and possibility to really work even at the beginning of the study in bachelor degree already on some experimental works. It's very open society, and it is very connected environment between the industry, engineering, and the physics. We saw these impressive pictures of ITER, and I was during my last 10 years job on many R&D facilities around Europe or even beyond, and I saw many big installations in operation or in decommissioning or in ITER case in construction, and this is something impressive. We see these big pictures, big massive instruments, and at the same time there is millimeters. There are single bolts and nuts and wires. There is a small physics, quick diagnostic. This is something really for me absolutely impressive, and that's why I was trying, even not continuing in PhD in fusion science, to stay in this environment, in this area of work. And I was thinking that there might be probably the question why I didn't continue in PhD, and believe me, there is no big deal behind. There is no big motivation. It was just like this. I after finishing my master in France, was trying to come back to Czech Republic and to continue there. I was looking honestly for some job where after some time I would be able to connect my work and some PhD study, but then there were waves of projects and many work duties, so there was simply no time on this. But this is the message I wanted to say. There is not big deal on it, and you will see that there is on a global scale many opportunities. It's not so important if people immediately decide to work at university, or it's not a one-way ticket. This is what I experienced during all the years when I was working. I was working always in project management or then in commercial positions, and in the following slides I'd like to show you some projects in the field of fusion or fission where I was contributing to, and only in a big and quick helicopter view on my work after graduating PhD. I am happy to say that I experienced to work for some engineering companies, which then the company Envinet became Nuvia. It's a big international company, so I spent many years in this kind of big international company with thousands of people. Then I experienced also the work in the companies which are not linked to fusion too much, but I was managing the company in not good conditions, means interim or crisis management of the company. This was, from this perspective, very good experience for me, even if the field was not in nuclear. And through the experience from the big companies, through the experience from the interim management of the company, I am now around 1 year working in 2 small companies, and we created these companies based on all this previous experience, and we are focusing on fission, nuclear, renewable energies. You will see further. So today I am associated with 2 brands, the companies which I also founded and manage everything. One is MIFRE Energy, and then the company very much linked to the nuclear in terms of shielding. This company we call M-Shield. This is an example of the project I am very proud to contribute on. And this is the installation in Czech Republic, which we finished in 2015. It's called Helča, and this is simply the testing facility for the primary first wall components. The installation is in Czech Republic. The first wall panels will be for ITER will be tested on this facility where we are simulating the heat flux of the ITER parameters. I was involved in the project mainly at the beginning because the years when it was finished I was already closing my work in Nuvia, but it is the biggest so far contribution on ITER from Czech Republic, so I'm very happy I was part of this project. Another example, but this is not the fusion. RŽH is a Žilorovec reactor in Kadaraš. Czech Republic has some significant in-kind contribution on the project, and I was involved in a project of the design and delivery of the overhead cranes. This is also a good example of the project where more countries are working together, which brings challenges, advantages, but at the same time it's really exciting, and from my experience from the study of the master program, I'm taking this, as I said, multinational experience from the study in the business. This is example of the projects when I was working in this company, not focused on directly fusion, but it was also very interesting work where we were delivering the projects to nuclear power. In Czech Republic, we were manufacturing heat exchangers, or this is the fuel tanks for Hinkley Point C nuclear power in United Kingdom. I selected these projects as an example of COVID influence on the business, because for many countries, for many industry, for many people, COVID was somehow game changer, and I must say for this big company, it was a very big reason for the current difficulties. As I said, the company is now in financial difficulties, and the COVID was really the reason. Big installations delayed, nuclear power plants postponed in schedules, but this is a life and experience, obviously. During the COVID, I was also participating and very, looking backwards, happy for the experience that I was a part of the Czech team, who was, it was really amazing time, was joining the Czech Technical University in quick development of the ventilator. It was really interesting time because the company I was working for, we made with Czech Technical University and of course dozens of other specialists. We made in 6-week functional prototype of some very simple in-use long ventilator. And then of course in every country, in every university focused on biotechnologies, there was this intention. So from this perspective, we didn't make nothing special, but I'm happy I was part of this, and moreover, we really finally also manufactured some units which were really in the operation. So in the end, there were people on situation of the need to use our ventilator. Of course, it was also a good experience for me, first time to work with media, public relation, negotiate with the politics. Everything was really in a quick way, even if in the end there is how to say, the failure in long-term perspective. But this is not important because it was not the motivation at the beginning to become a new company in the map of the medicine instrumentation manufacturers. It was a good experience. But now my current work or other projects are, as I said, focused on the M-Shield company, where we are doing radiation shielding projects for research and development facilities for nuclear power or also for nuclear medicine, for example. We are building, as you will see, different shielding structures, bunkers, walls, or some on the instrumentation shielding assemblies. And then I'm working in MIFRE, where we are trying to develop the broader view on the 3 areas where I see the future today. And this is renewable energy and waste, conventional waste management, where we are developing and putting on market different technologies for processing of the normal waste. Automated robotic workplaces. This is area which is not only in automotive industry or some components manufacture, but it's going everywhere. And then nuclear industry projects, because as I said, Czech Republic is very much in fission. There is going to be a new build of nuclear power plant in Dukovany site, and that's what is the third sign. Now we are working on the build of some administrative and technical base workshops, buildings for supply chain of the new build. But this is something which will be in 10 years from now. Now, I want to show ESS, European Spallation Source. This is under construction, the European facility in Swedish University City Lund. And we have there many projects. I was there first time 7 years ago, and currently M-Shield and MIFRE, our companies, are delivering several shielding caves. So we are quite proud that from Czech Republic we are able to win these tenders and supply the structures in Sweden. We are delivering also some control rooms, and I'm happy that we were also successful in procurement to develop and then deliver the carbon borate neutron shielding tiles. For me, it was a little return in the research, and I must say that we have really the unique product for the fast neutron shielding, which we didn't find nowhere in the world. We also manufacture and delivered on ESS beam dumps and other small items. Then, as I did say, we are doing also other things in MIFRE, like mobile photovoltaic installations. We have some robotic workplaces, just for fun maybe, because we are doing different wooden things on the robot in the containers. And this is example of the technology which we developed for the processing of the organic waste. Gastro waste is something which is topic now in this area. But this slide I wanted to show only for you understand that even if I work in a company where we are trying to focus on the fusion or fission technologies, we must always stay also somewhere else to be stable, because, as I did say, example of COVID, the world is changing, and to think that the plans will stay the plans, to think that the budget stay within the budget, and where we are today will be also tomorrow, this is not working. And I'm, from this perspective, happy for all these difficulties I experienced during the COVID in the previous activities. Last slide, because I know we are in delays, is this. I'm happy we, in fact, in our company, MIFRE, designed and then manufactured and installed, we operated this plasma lab. In the Czech Technical University, there is a Faculty of Nuclear Science and Physical Engineering, and this is a remotely in operation laboratory where we provide 8 plasma experiments. And this is a new thing. Just at the beginning of this year it was opened, but there is already some students working on. So I think that for all of you who are somehow connected in your studies with the Czech Republic on Compass or Golem, now you will be definitely seeing that there is now new laboratory in the university. So I'm happy we did this. It was, for me, very nice to also come back and to see a little bit what I studied, because honestly, I forgot a lot of things already. But I know that I understood these years ago, so I believe that I will understand again. So I'm finishing my presentation with the invitation, because we will be on the booth on the Big Science Forum. This is a quite new conference. Before COVID it was only once, and now it will be again in October in Grenada. This is a conference which is bringing on one place all nuclear research and development facilities within the Europe. Not only to share the knowledge, the facilities in operation, in construction, but also in preparation phase. So maybe somebody will be there, and we will be there as well on the booth. So thank you very much, and maybe there are some questions.
Thank you very much, Mr. Michal Kazda, for giving this broader view. Also, fusion is not only about the plasma, there's much more, and in fact we are going to have to deal much more in the future with all the ancillary equipment in and around the plasma. And also the spin-offs with other industries, of course, and the relations with other industries. Perhaps one quick question?
Thank you. Very nice presentation. Just to ask you, what is the role, the complete role of MIFRE in the large project that you presented, like the heat exchanger and so on? Did you make the design, engineering, fabrication, installation, and so on? And what is the number of employees of MIFRE Foundry?
Thanks. So this heat exchanger business, it was in the company where I was working previously, and which is now on hold financially. There was 250 people, and it was in the company Miko. Everything That means the design and the installation transport. Usually these big components are installed on construction site by the general contractor, not by the manufacturer. In fact, MIFRE is a small company, 12 people only, and these people are from this previous company, which kind of split into small activities. So this is only 1 year company with 12 people.
All right, thank you very much. Let's thank Mr. Kazda again.
Thank you.